All right. Super Saturn. That's what we're talking about today. Super Saturn J1407b. That's what they call it. The true Lord of the Rings. Because this planet, remember, it's an exoplanet. It's not in our solar system. Let's write that down. Not in our solar system. It's in our galaxy, though. Keep that in mind. It's in our galaxy. It's not. Let's put it over here. Not. Oh, we're going backwards today. What's going on? It's not in our solar system. And its ring systems are at least 100 times, or maybe even more, 100 to 200 times greater than Saturn's ring system. So it's an exoplanet, and it may even be, put in parentheses here, a brown dwarf, and I'll talk about that later in the video. Could be a brown dwarf, a failed star. So exo means, just exactly what you see here, out, right? It's exit in Latin. So it's out of our solar system. And it's orbiting a star called V1400, V1400 Centauri. So it gives you a hint of what constellation it is. It's in the Centauri system. Centauri system. Of course, in that system, you see Alpha Centauri, Proxima Centauri, which is our nearest star, and so forth. So this super Saturn, this J147b, is about, we'll put a little about sign over here, it's about 433 light years away. So remember, a light year is about 6 trillion miles, so it's farther, it's pretty far away. Whereas Alpha Centauri, well, let's say Proxima Centauri, our nearest star besides our sun, which is in the same constellation, is about 4 light years away. Fix that G. 4 light years away. All right, let's get more details. Oh, and I did say Centauri system. I meant in the constellation of Centaurus. The constellation of Centaurus that you can find in the southern sky. That's where you'll find this exoplanet and Proxima Centauri, Alpha Centauri, and so forth. All right, and here's an artist rendition of the planet. There's the planet over there. Get our pen going. Get our pen going. There's the planet or the brown dwarf, which we'll talk about. It's much, much bigger than Saturn. It's about 20 times bigger than Saturn. 20 times bigger than Saturn. Or more, right? Still studying it. But its ring system goes out pretty far. It's about 100 to 200 times greater than Saturn's ring system. So if you think about, let's say, here's this, let's just put the sun here. Let's say that was the sun. And not in the diameter, not in the same ratio here. I'm just saying, if that was the sun, and let's say that was Venus, right? And here's Earth, let's just say. So from the sun to Venus, there's about 75 million miles. Sorry, not 75, 68 million miles. So from this planet, let's call it, you know what? Let's say J1407b. That's the planet's name. Let's just call it Rhea, because Rhea was Saturn's sister. Of course, that's not its name, but in the video, I'm calling it Rhea. Maybe it'll catch on. So if we went from Rhea all the way to the end here, end of the system over here, that's 75 million miles. So if this was the sun, let's say, and again, the sun is much, much bigger than Rhea, and then you went up to Venus, and let's say that was Venus there, right? Venus is about 68 million miles. And the Earth, and the sun to Earth, by the way, that 93 million miles. And of course, it does change because the Earth is closer to the sun in certain seasons. Like, for example, it doesn't seem that way, but Earth is closer to the sun in the winter in the northern hemisphere. So this is just in a general distance. So that's enormous. That's an enormous amount of rings. And there is a lot of gaps between these rings. And a lot of scientists think there are moons, of course, because exomoons. Exo meaning out of our solar system. There could be moons and other debris within these rings, and there are these large gaps. So that's why they think there is a possibility of moons living in these rings of Rhea J1407b. All right, so let's clear this out. So I can think you get the point of how the distance of these rings and where they would be if they were in our solar system. Again, they would, if it was the sun, again, those rings would just go out past Venus. So it's an enormous amount of diameter we have here. But let's clear this out. There's our artistic picture of it again. So is J1 407b or Rhea? Now again, no one's calling it Rhea but me. Maybe it will. Maybe someone will catch on and call it Rhea. Is Rhea a planet or a brown dwarf? Now, brown dwarfs are failed stars. Jupiter is not a brown dwarf, so it's not a failed star. You could say it's a failed brown dwarf, maybe. Brown dwarfs are usually within a range, and this is what scientists say, around 13 to 80 times the mass of Jupiter. So the mass of Jupiter, and Jupiter is about, and the is got disappeared in that light there. Jupiter is about, put it over here, is about roughly maybe 2 times the mass of Saturn. So if we take that logic, maybe we can say that, put a box over here. So if Saturn, they're saying that this possible brown dwarf maybe is 20 times more massive than Saturn. So Rhea maybe, we shouldn't say maybe, we say approximately 20 times the mass of Saturn. So maybe Rhea is 10 times the mass of Jupiter. In that case, maybe she isn't a brown dwarf. Because remember, we said 13 to 80 times the mass of Jupiter. Or maybe she is. So there's a debate on whether she's a brown dwarf. Now, again, brown dwarfs, just to let you know, brown dwarfs they went through a nuclear fission. They were fusing hydrogen, not fission, nuclear fusion. They were fusing hydrogen into helium. And what our star does, and stars will do, they will fuse 4 hydrogen atoms. There's those little hydrogen atoms into an helium atom. And so they will do that. Our sun is doing that now. And brown dwarfs will do that, but they do not have enough mass to keep that process going. So eventually what happened is their fusion process stopped. And that's what brown dwarfs are. So they're in between, a Jupiter-like planet and a star like a red dwarf like Proxima Centauri, our closest star. All right, that is the Lord of the Rings, J1407b.